Hey guys, so we have still one more video to do, and that would be our scientific notation video. So scientific notation is a very specific way of expressing exponential notation. Many of you remember exponential notation. I think most people start learning it around middle school. But with exponential notation, the amount of digits here can change. With exponential notation, that number is always between 1 and 9.99999. So for instance, 100 could be expressed as 1 times 10 to the second. 1 million is 1 times 10 to the sixth. And 0.01 is expressed as 1 times 10 to the negative second. So what we're going to do is going to go over two sets of examples. The first example is a number that is over 1. So we have 375. And this is the process that we use in order to write scientific notation or take a normal number into scientific notation. First, we're going to put our decimal after the first non-zero number left to right. So our first non-zero number left to right is this 3 right here. So this is where our decimal is going to go. So we're going to put our decimal there, and then it'll say times 10 to the something. We're not quite sure what that something is yet. We haven't discussed that part. But if we were to shift that, our decimal would wind up right here. And that should be a question mark, though. It's kind of hard to see. So then we're going to go back to our original number, and we're going to look at how many jumps we made. We made 2 jumps. To get from here to where our decimal is here, we moved our decimal twice. That makes our exponent up here to the second power. Now, anytime the original number is bigger than 1, this will be positive. So again, we look at our root number, we put our decimal after the first non-zero digit, then we look at how many jumps we have to get back to our original number, that's 2. And if this number is bigger than 1, then we leave it alone. We leave our sign the same. Our second example is a number that is smaller than 1. In this case, we have 0.0532 grams. And notice that these are measurements, so they have both the quantity and the unit. And we discussed that in our last video. So our first step is to take this number and to put our decimal after the first digit. The first non-zero digit. So if we did that, our number would go from here to here. Now, I acknowledge that, my paper's not coming off very smoothly today, but that's okay, because we're not good about perfect. We want to be accurate. Also, I want you to see that I literally moved my decimal after the first non-zero digit. So my decimal went right there, okay? And then I have times 10 to the question mark grams. So our next step is to look at how many jumps we made. Well, if we look at this, we went from here to here. We went from here to here. That's 2 jumps. So our exponent now looks like this. And between steps, what I want you to see is I just kind of erase these front zeros because they don't matter. But once I understand that there's 2 jumps, I now can put the 2 there. Now the question many people ask is, when is it negative? It's negative because this original number is smaller than 1. So you're always going to look back at your original number that you started with, and that's going to determine whether or not this number is positive or negative. If the original number is greater than 1, this will be positive. If it is smaller than 1, then it will be negative. I also typically do not teach this in the move to the right, move to the left way, which is what many of you learned. The only problem with that way is that some of you look at this original number and move the decimal, and some of you will look at your final number and move your decimal. And depending on which way you looked at the numbers, moving the decimal to the left or the right will totally confuse you. But this way is consistent and the same no matter who is doing the problem. And that is that you always start with your original number. You move your decimal behind the first non-zero number. Then you look at how many jumps it took to do that. So in this case, that was 2 jumps. So that's where this 2 comes from. And then I look back at my original number. It's less than 1, so it gets the negative. Alright, so here's the point where you try it. Now here's the way try-its work. I would like you to try these few problems. Put it on pause right now, try these problems, and then come back. Now, I know some of you are going to want to play it straight through, but you need to see if you can actually do this. Now, if you can't do it, what you want to make sure is that when you come to class that you ask questions specific to why you're having trouble. did the great first problem, fine, but I had trouble with the second problem. Or maybe you'll see what mistakes you're making automatically, and then we don't have to deal with that at all. So we have 0.3272 grams. Pause right now and give it a go. So theoretically, you actually push pause, and I know there's going to be some of you that didn't, but hopefully you did. What you would have found is this first number is 3.72 times 10 to the negative 1 grams. Again, I'm only moving my decimal place one step. That's where the 1 comes from. And it's negative because this number is less than 1. Now, some people get confused about what happens when there's a decimal, a number after this. And so what I want you to see is that the only thing that changes is our very first digit, or our very first part rather. So this part stayed the same for both of them. I just added another digit in, okay? A number like this, I'm going to have to put my decimal after my first non-zero digit, which would go here. Then I have all these extra zeros, I'm just going to drop those, okay? Now, if you left them for now, that's fine. I'll explain why you drop them later. And you would wind up with 1.003 times 10 to the 6th. This number stays positive because the original number is greater than 1. If you wind up with a number between 1 and 9.999, your number will actually wind up being, your exponent will wind up being 0. We didn't do any of those today, but we'll do a couple in class. 240 centigrams. That's going to become 2.4 times 10 to the 2nd. Again, you could, at this point in the school year, have 2.40 times 10 to the 2nd. That would be equally correct at this point in the school year. Later on, we'll talk about why we drop those zeros. And last, but certainly not least, this one, 3,502.3. Now, this is a little tricky because for some reason, whenever we see numbers past the decimal, students get confused as to where to move your decimal. But you're always going to move the decimal to the exact same spot every time. And that spot is right after that first digit. So, it will look like this. And when we count, I move my decimal 1, 2, 3 spots. So this is 10 to the 3rd millimeters. Also, I know I reminded you of this before, but I want to make special emphasis that each of these numbers has both a quantity and a unit. It's important that you have both. I guess that's it for this week. And later this week, I'll put up an additional video to help you with a new concept that we're doing in class. This video won't be required, but it definitely will help you to understand dimensional analysis or factor label method. If you'd like to go ahead and look that up online, feel free to do so. It'll help you out a lot. But if not, we'll cover it in class probably around Thursday and Friday. Thanks so much, and I'll see you next week. Bye-bye.